Okay. So I'm going to talk a little bit about server scalability and try and make this quick, actually. Maybe we'll catch up a little bit. So I'm the manager of operations development. I'm responsible for making sure everything scales and can be operated, and that it logs, we know what it does, and it's reliable, and we can monitor it and know that it's working, things like that. I guess we'll start off with the base scalability goals. The DPR that we put out right now is suitable for use by fully dozens of people at the same time, which really means that we did no performance testing, so we gave a really low number because we know we can support that low number. The alpha of the 1.0 release similarly will not support a huge user base. It'll support 1,000 users, suitable for technical trials, use within cable companies' offices. It's not a great choice for large commercial deployments because it'll scale well to handle 1,000 subscribers, but once again, it won't really receive the full testing for scalability to large installations. Yeah.
I have a quick question.
Yeah.
From a non-technical person.
Sure.
What happens? I realize that you guarantee to that certain.
What happens if you put more?
Yeah. So what happens when you put more on an earlier release? What do you guys do to go from 1,000 to 100,000 in very high level terms?
In high level terms, we try it and we see if it works. Okay. Certainly, from the beginning, we have to design so that it'll support 100,000 or 10 million. And, really, in terms of design, the goal is millions. It's greater than 1 million. And so we won't do anything up front that we think will interfere with the goal of supporting 10 million users. Okay. We might have done something inadvertently.
Okay. Yeah, you're not designing one for 1,000 and then saying we're going to change the database now and size it and all that stuff. You're actually designed for the high water mark and then just don't get around to testing and QAing it until these times.
That's right.
Yeah. But Jim, one thing I've been wanting to ask now for a month, I keep forgetting.
Yeah.
What are the issues in scaling, say, from 1,000 to 1 million?
We'll get there. We'll get there. So 1.0 beta, we will test and certify to support 100,000 subscribers, which I think is larger than any of the installations we expect to see based on beta. Beta is suitable for field trials and should have a higher level quality. The 1.0 RT release will support 1 million subscribers, and we'll have tested that. We'll know that you can support 1 million subs. And as I said, the design is intended to work for much larger bases than 1 million. So post 1.0, it should support many million without a whole lot of trouble.
So is that a hard limit that is hard-coded in essentially?
Nope.
So you just guarantee it for that?
That's right. That's a number that we will have tested and verified that it works. All of these, certainly the early release, there's reason to believe that you could do more than what the numbers are. We can't tell customers that because we will only have tested these numbers. The architecture for allowing the service to scale, and one of the reasons we believe we can scale up to a large service is that when you make a Microsoft TV installation, you essentially build a bunch of mini services, and we call those service groups. Each of the mini services is intended to be almost a complete service. It has most pieces of MS TV server, and that's actually the piece that we do performance testing on. So when we say we support 1 million subscribers, that doesn't actually mean that we have a lab where we're going to build up a 1 million subscriber server. We're not going to do that. That actually costs a lot of money. And it actually wouldn't have a lot of benefit. What we're going to do, we're going to build up a service group, support some number of subscribers, let's say 50,000, and we will test to make sure that that supports 50,000 users. And then we know that we can add more of those, and since they don't have any dependencies, we'll scale up linearly. And that works for many of the components of the service, but not all of them. And the reason that works is that there are no interdependence between the service groups. Two service groups will never talk to each other. It's not like when you add more service groups, they start getting slower because they're talking to so many groups. They don't talk to each other. They're independent. And in the future, when we support geographic distribution of the servicer, this will be the unit of hosts that you can put in a different city in a different data center. Yeah.
No interdependencies, but you do have separate databases for each service group, right?
Mm-hmm. That's right. Fun should ask that.
That seems to be a dependency.
You're right. There are some shared components between the service groups. Actually, we can jump ahead to there. Well, actually, I'll show the diagrams first. So this is a service group. It doesn't have all the components represented on it, but it's got a sort of representative sample. There are a bunch of front-end machines that run applications like home, centers, search. The operators can actually decide exactly how to divide the applications between hosts. But you would expect some of the higher load applications will be on dedicated machines. For example, the reformatting proxy will almost certainly be run on separate hardware from everything else because it's probably the most heavily loaded service, and it also has slightly different hardware requirements. It requires a lot of disks, for example. You could imagine they'll combine a bunch of the UI applications because they're fairly similar in terms of their requirements, and they probably do quite a bit less work than the reformatting proxy. Operators that choose to use server-side cookies, they may well deploy those on separate hosts because they get a lot of load. But favorites and mail, you wouldn't necessarily have to put those on their own machines. Then within a service group, there are a couple shared components that a lot of different servers access. The most important is the main subscriber user's devices database. You'll hear this called the SUD a lot. That's the database that stores information about subscribers, users, and devices. And it's worth noting that each SUD only has data about the users that are assigned to that service group. That is, for any given household, all of the data for that household will be exactly one service group. Whenever they log in, they'll talk to the servers in that service group. And it can be moved to another service group, but it's an administrative operation that you wouldn't do routinely. You don't do it dynamically to load balance or anything like that. The mapping of users to service groups is generally static. The second important shared component of a service group is the user store. This is the store that we use to store some higher volume data that changes more often and that we don't necessarily need to protect in a transactional database. So examples of that are cookies and favorites. Both of these applications store the data in the user store. And right now there's some investigation going on what the best user store to use is. We have an implementation right now on top of the CIFS file sharing protocol, Microsoft's file sharing protocol. We don't have it. It's being implemented by a contracting firm. And we have an implementation on top of SQL 7. And so right now we're doing performance numbers to figure out which one we actually recommend that customers use, or both. If they use SQL 7, actually these two classes of machine collapse into one. You could imagine putting the database and the user store database in the same machine. So when we scale up to a larger service, we take a bunch of these units and we replicate them. They have no interdependencies, but they all talk to several global components. So every SUD database is going to talk to a global database, and this is the answer to your question. The database do need to share a bit of information. So there's a small amount of information replicated up from these to that database. And so this database actually does have to scale. The bigger the service, the bigger this database. So this is a scaling point for the service. However, that database does very little work. We actually don't believe that we'll run into some problems with it until we're up at many millions of users. Similarly, there's a log aggregator that aggregates logs about what's going on all these services. All these services, every machine logs information about its activities, but if it's distributed across 300 machines, it's really hard to get anything useful out of. So we take those logs, and every machine sends its logs up to this machine. So this machine similarly has scale to support a large user base. And in the one time frame, it's likely that there'll still only be one or a small number of these in a service. There won't be one service group. So this is another component we have to worry a lot about scalability of. And then the final global component is the data warehouse. If a subscriber deploys a data warehouse, in the 1.0 time, it's one warehouse for their subscriber base. So that'll actually be quite a big database installation.
Is there going to be an exercise to be able to provide sizing documents that will include both the relative size of machines, but also the bandwidth between the machines? In other words, you kind of get a picture for, bigger than a bread box, here, right? I know you guys have more detail on the size of the machine, but what about the bandwidth, the communications between them? So you take a one user scenario and you say, okay, roughly this is how much communication we think will happen, we'll model, right? Between the data warehouse server and these servers. And so this is the kind of pipe you should put in between those machines.
Yeah, that's a good question. I think that we'll have to provide some of that information. We need at least basic recommendations. As you add more service groups, I haven't drawn all the networks in here. A couple networks. All the machines are probably dual-homed. And there is certainly a point you reach where you need to start splitting those networks into separate subnets.
Well, some of the operators, maybe most want to actually spread this physically, right?
Yeah.
So you talk about links in between the different. We won't get into that right now, but
right. Yeah, that's the whole.
Bandwidth.
That's a whole other subject. I think that we have some work to do to figure out what sort of geographic scaling we support well and what sorts we don't support well. If you took the service today and you distributed it geographically, you could do that with appropriate links between them. But right now there isn't logic to make sure that, for example, users go to the servers that are to them. So I think we'll have to add that in 1.0 product plan, but that discussion is going on right now. So my take on this is that what we need to do is figure out exactly the geographic distribution models we support for 1.0. I think the plan of record actually says none of them, but I think we're discovering that's not realistic. So we need to carefully choose a very small set of the possible geographic distribution models and then document those. So I agree with what you said, and we haven't figured that out yet. So as I said, there are a few components that really have to scale up to support the installation size. If you have 1 million subscribers, global database has got to handle 1 million. The log aggregator has got to support 1 million, and the data warehouse has got to support 1 million for 1.0. In terms of how we're going to test that, as I said, we're going to build one service group. We have the machines on order. They should be in a few weeks. And we've got a performance lab that'll be up on Charleston Road. So we're going to rack up a bunch of machines in the lab, and we're going to build out services like you'd have in a real service group. And then there's a Microsoft load generation tool that we've got called Homer that we're teaching to simulate a web TV client. So we're going to run a bunch of machines simulating clients, and we're going to have talk to the service machines, and we're going to deliver what we hope is a very realistic load and see how the servers do. And if they don't meet the load, then we're going to have to go in and analyze what they're doing, what they're not doing right, what's taking so long. It's worth noting that in terms of schedule, much of the performance work is a little later than most of the other features. The features will be complete in the alpha release, but the performance work will not all be in the alpha release. That's why we have the not very optimistic goals for scale for the early releases. A lot of scalability work really comes in later in the product cycle, and so it's the beta and the RTM release that you want to look at for large-scale deployments. Then the separate components that we talked about a minute ago, the database components, the aggregator components, and so forth, we have to separately test because we're not going to build a 1 million subscriber service in order to test the global database or in order to test the aggregator. So we have separate test plans for those, particularly the database and the aggregator. The data warehouse scaling, actually, I'm not quite as familiar with what we're doing. I'm not sure that whole story is known, although to a large extent, that's the SQL Server group can help us out with because they know a lot about how their product scales. So this talk was originally titled Scalability and Performance. In some sense, there are two issues that really matter for this product. One is how many subscribers can we support if cost is no objective. But in terms of performance, you do run into bottlenecks like that, right? eBay is a really large service. If they could spend $50 million and scale bigger, they do it. They don't care about the cost, but they actually have run into hard limits. So scalability is the first question. Where are the absolute limits where no matter how much you spend, you can't scale any bigger? But the second thing that's really important for this product is the capital cost per subscriber. And so when we talk about performance back check, that's actually the number we talk about. It's not how many tenths of a second it takes to scrub the home page. The main metric is capital cost per sub. In a broad scale, the goal for capital cost per sub is to be in line with the WebTV service. We actually expect to be cheaper than the WebTV service, but that's kind of the line for accepting this release. There are some spreads floating around that estimate what the WebTV service costs per sub. I'm not going to try and quote them in this meeting, but and then I think as we go in yeah. So and then we're trying to drive that down. I have to make one big caveat, which is that the cost of the service depends a lot on what the user of the service do. As you look at operators, we may have some operators that deploy one of these set-top boxes to every sub on service, and it may be that 75% of them never sign up for web service, only have access to a very small walled garden, and may not even use it. We will have other cable subscribers where the only people that get this box are people who sign up for web service, and so every user will be a heavy user. And so capital cost per sub is a very slippery concept too. Right now, we're probably biased towards capital cost per active sub, but for the moments where we deploy a large number of boxes to people who aren't going to use them a lot, once again will probably handle significantly more subs. And I don't know that for 1.0 we're going to have it quantified really well, but as we learn about the operator's usage patterns, actually, we start talking about cost per sub for modes of usage, because there will probably be an order of magnitude difference between what you can supply active service or less active. Yeah.
What kind of thing goes with the
When I refer to capital cost, I essentially mean the cost of the server hardware and the networking equipment. I'm not including, for example, operator salaries. I'm not actually including physical space directly when I talk about capital cost, although that's sort of proportional to hardware costs in a lot of ways. I think that's roughly the list of things. I definitely don't include set-top boxes. Just as an aside, it is interesting if you look at sort of the cost structure of these things. The set-top box is probably number one, and my personal view is that customer support is way number two, and server machines are probably number three. So that's another important thing to keep in mind too. Yeah.
You said this and I missed it, but what happens if you scale, from 1 million to 10 million? Does the cost per subscriber go up, down, or stay the same, or you don't know, or you don't care?
Well, if we didn't do any releases between the 1 million and 10 million, it would probably be roughly linear, because service groups cost the same amount to build, right? And so you just build those out. The only things where it becomes more interesting is when you start talking about the shared components, the global database, the aggregator. The global database, you could get to 10 million and not spend very much on it. It's sort of irrelevant. The aggregator is going to go up roughly linearly. The data warehouse probably goes up more than linearly. You're talking about Big Iron have a 10 million sub data warehouse. Although the data warehousing group has plans for how to keep that cost down. If you have 10 million subs, you could choose not to store every hit of every subscriber in that database if you didn't want to. So there's actually an architecture in place now for sampling of data so that you can get good aggregate number on your users, and you can get specific data for every user on this you really care about, but you can throw away 8% of the data on the way to the warehouse.
So your answer is you really don't know.
About the cost going up?
About the cost per subscriber as you go, say, from 1 million to 10 million subscribers.
I think we know for most of the components except the warehouse. And the warehouse depends on the decisions you make.
Overall, bottom line.
It scales pretty linearly because of
Yeah.
the service group concept.
Yeah.
So you should have this little complex for 50,000 users. You just keep going it. So you just keep going.
Yeah, sure, it's linear.
Right.
The groups are linear, but like
I
I'm
know the
saying,
warehouse, yeah.
your new cost on your data warehouse not going to change until you get a million.
Right.
So actual cost per subscriber is dropping for a while until you get to the point where you overloaded your shared databases, and then at some point you got to scale those up, there's going to be another increase in cost. But you don't know where the point is.
That's right. In a lot of ways, it depends on your strategy. You can choose to deploy a service with a very small data warehouse and grow it very conservative by a little bit bigger and a little bit bigger and a little bit bigger and rely on the trade demand from your hardware manufacturer. Or you can choose to buy a big one up because you know you're going to get big.
We did a best case for Charter, and we had like $4.10 per sub for the 50,000 user system, and it went to $1 million. It dropped to like $8.40.
Okay.
Yeah.
But we scaled like you described with a bigger warehouse up front,
Right.
With a bigger cost.
Right.
But just to be clear, though, the warehouse was sort of some unknown. We made some pretty wild assumptions.
It was
Right.
There's a lot of unknowns around the warehouse, so we made just some wild assumptions.
Oh, okay.
We're not sure if those are true, but I think we had a pretty good handle on the rest of it.
Yeah.
It's just the warehouse that could easily pull those numbers out.
Yeah, I mean, in some sense, the warehouse is probably a weird curve. Where, like, when you're small, the warehouse is very expensive, right? And then as you scale up, it's less expensive because you have greater utilization of the hardware. And then as you get really big, if you don't start throwing out data, it goes up because expensive hardware is not linearly more expensive. I mean, high-end hardware is not linearly more expensive than low-end hardware. It's kind of exponential. So by the time you're buying 16-way machines to do it, you're at a very high cost per sub. So somewhere around here, you don't want to start throwing out data unless your business can justify spending this much money on your warehouse. Maybe it can. I don't know. So the answer in a lot of ways is that the operators will be able to choose. However, this line is really post 1.0. We expect to support 1 million subs on one data warehouse machine within a manageable size. You don't have to be like talking to Cray to run 1.0. So that's actually most of what I want to say about performance right now. Anybody have more questions?
The other cost I think that's there, but it is a little bit different. We have different issue, but is the operations cost.
Yep.
Because I think that's where we win from a business perspective in the marketplace. Is first your CapEx is important, but then if you have to have an engineer beside every little machine watching it, your overall total cost is crazy.
Absolutely.
And I do actually think I'm pretty bullish that I think our ops costs will be very low because of the good design of the architecture, but we need to get some science behind that.
Right.
And we can start putting that out in the marketplace and say, look.
Well, I'll make another assertion, which is in terms of the overall cost structure, the quality of the user interface may dominate the hardware cost. If you look at the dial-up server we run, which in some ways is similar, in ways isn't, we probably spend, taking $25 a month, we probably spend 8 to 10 on connectivity, which is totally different in the cable space. We probably spend 5 to 8 on customer support, and we spend less than 2 on all the hardware and operators put together. So if you look at where optimized, if you fix a user interface problem that results in customer care problems, you can save more money than all the software optimization you can do in the world. And that's going to be a really interesting thing to try to measure.
Yeah. So
Yeah.
it's good that we actually share that experience in a way that gets cable operators and our network operators, focus on the right problem.
Yeah.
Because our competition likes to focus on the stuff that, get them all excited about, one metric. And then they come to us and say, your price is too high for your software, right?
Yeah.
Or whatever the metric is they're worried about. And then all of a sudden, we need to show them that.
Absolutely.
I think that's actually a great point.
Yeah.
That's a great point.
And honestly, one of my fears is that the operators don't understand the customer care ramifications yet.
Exactly.
Because
They've really done a good job.
yeah. If you'd said that before he'd said it, then I would have been more prepared to do it. Here. Speaking to the mic.
Prashant's got it.
Yeah, Prashant will put it in the notes. Yes.
So, to summarize, the reason why you guys have designed service groups is one, for scalability, right?
Yep.
Any other big reason why?
Yeah, actually, scalability is number 2. Number 1 is for fault isolation. One of the problems that running a service like this is, the WebTV's US service has probably 400 machines right now, and if you add up all hard disks, it's like over 1,000, maybe 1,500 hard disks. Turns out that there's a disk used to be failing every day, and so you have to assume that at any given time, one or more machines will be down, and so we try hard to have all the machines be redundant, so that whenever a machine fails, it's not a fire drill. You don't have to fix it right away. But if there are dependencies between machines that we don't catch, the service group structuring lets us do is make it if a machine goes down, the only users it can hurt are the users of that service group. So the worst case scenario is you lose.
They're not necessarily hurt, right? Because you fail over another machine.
Right, but say that something fails catastrophically. Say you lose a switch. Say you lose that database machine. Say that database machine is a clustered machine, but Wolfpack fails you, and you use database service. For most kinds of failures, the largest system-wide failure you ever get is one service group. And so that fault isolation is very important. It knows that if a machine fails, and so you roll over backups, you want to figure out what users might be impacted with lower performance. When you get calls, you know whether they're reporting a problem that you already know of or a problem that you don't know of yet. With service groups, you know what machines failed, and you know what user that could impact. And so if some other user calls up, you know that that's not the cause of their problem.
So it facilitates.
Yeah. Otherwise, as your service grows, the problem diagnosis is much harder because any given user would be hitting any given front end, which is sort of the Hotmail model actually of until recently. And so when you do have problems, the problems tend to be much more service-wide, whereas in this architecture, the problems tend to be much more limited to a small set of users. It also means that if you register users into a service group, it doesn't hurt everybody. Only that service group starts to slow down. You can solve it by moving them into another one.
Okay. So it helps you manage your whole operation.
Right.
But was another reason for service groups to lower capital costs of subscribers?
Nope. Actually, I think it probably marginally raised capital cost per subscriber. There is a third reason, which is versioning. When you roll out a release, the last thing you want to do is put the new release out to the whole subscriber base, which is sort of another classic Hotmail. How do you put out a new version to Hotmail since everyone's hitting all the same hardware? You can version one service group at a time. So, for example, you might have a small service group that you just use for some users that you're friendly with that are willing to test new stuff. And when you roll out a release, you might send a release to that service group first. And so they run the new version, you see how it works. Then maybe you roll it out to one full-size production service group, and you see how, you've already lab testing, but you test it with real users, and maybe you'll catch something you didn't catch in all your QA testing and small group testing.
You're setting up the test.
Yeah. Once you're confident, you can roll it out service group by service group.
So you can design users to specific service groups?
Absolutely. Every user is assigned to a specific service group. Actually, every subscriber, all the users in a given box are all on the same service group. And when you start geographically scaling, you want them to be assigned to service groups as to where they are.
So is there a strategy for how users
Today there is not. I know, honestly, I'm not quite sure what the code does. I know in the Solaris service, at any given time, the operators can say this: all new user registrations could go to the following list of service groups, and it just round robins between them. I think we probably do the same thing, and that lets you sort of have this fire hose that's pointed at one or more service groups, and then when they start filling up, point it somewhere else, and you point it somewhere else. I think we're going to have to, we may have to do better than that as we start seeing geographic scaling, having some smarts about when you use registers, you figure out what part of your network they're coming from, and then you put them into something close by. So that's something we're talking about right now. How much that'll be in 1.0, I'm not sure. Okay, any more questions?
Okay, so let's turn it over to Suresh now.